Sorry for the interruption. My dog got distracted by someone walking by. So we are back to here, the parent function. So our parent function for quadratics is just like all of our other functions, we have parent functions for them. It's the most basic, easy one, and it's y, or f of x, equals x squared. So that's our parent function. And like a lot of other ones, like most of them, the vertex, or the starting point, is at 0, 0. So right here at 0, 0 is my starting point. So 0, 0 is going to go in the middle of the table. And my axis of symmetry is x equals, and it's going to always be, for your axis of symmetry, the x value of the vertex. So that 0 has to go right here. 0 for my vertex goes right here. So the x equals 0. And then we always draw our axis of symmetry as a dashed line down the graph, and we label it. And we also label our vertex, because those are our key parts to this. Now, on our table, we're going to go 2 points higher and then 2 points lower. So we're going to go in 2 values in both directions from the middle, so from our x value of 0 here. And the way you find the y values is just like other equations. We simply plug it in. So if I plug 1 into x squared, that's 1. 2 into x squared is 4. So I have 1, 1 is here. 2, 4 is up here. And now remember, our axis of symmetry is the middle of our graph. These points, that's 1 away here. So 1 in the other direction is going to be here. So we're going to go negative 1, 1. And 2, this is 2 away, so 2 in the other direction is going to be here. Negative 2, 2. Or negative 2, 4, I mean. So I'm going to have negative 1, 1, and negative 2, 4. Put that on my table. And then again, notice your table, this is the vertex, the middle, and it repeats around the middle. And this happens when your x values are equal distances from the middle. You find this repeating. So now we'll draw our parabola in here. There's one side and there's the other side. Not super easy to draw on this pen, but I do my absolute best. The so what that is very important for this, that you want to make sure you do, I'm going to put this right in the middle here, try to, is you always need to find the middle first. And that middle is the vertex. And we have to find that first so that we know where the middle of our graph is going to be. Because if you don't graph the middle of your graph to start with, then you might just see what looks like a vertical line of your parabola. You might just see half of it. So we've got to find the middle, put the middle in the middle of our table if we're using a table, and then also make sure we graph the middle of our graph first. All right, let's look at vertex form. Vertex form looks like this. It looks like y equals a times the quantity x minus h squared plus k. Looks a lot like our absolute value equation. So the thing that you have got to remember here, I'm going to put a note here. Remember, these always form parabolas when graphed. A common mistake is when students graph these, they don't make them in the shape of a parabola. They kind of draw straight lines in between the points and make it look more like a V. And V is for absolute value. These are parabolas. Our axis of symmetry is going to be x equals, and again, it's the x value of our vertex. And our vertex is real easy. This is why it's called vertex form. It's really, really easy to see. It's not a special name. Here's our x value of our vertex. And here's our y value of our vertex. And notice this is a minus sign, so it's the opposite of this right here. It's going to be the x value of your vertex. So it's just h comma k. And then again, like I said for the parent function, your axis of symmetry is x equals. It goes through the vertex, so these x values match right here. So let's graph this. So here's how we graph. We're first going to start by plotting our vertex. And our vertex for this one is going to be the opposite, so -1, +6. So my vertex is -1, 6. -1, 6 is right up here. Now, I know my graph's going to open down. And the reason why I know my graph is going to open down, if we remember from absolute value equations, this negative tells me my graph opens down. This 2, for absolute value, it told us a slope, but we're not doing absolute value, remember? These always form parabolas when we graph them now. It's because these are parentheses and are squared right there. So that -2 tells us if we go 1 from the middle, we're going to go down 2. 1 from the middle, down 2. It only works, our A value now only works going 1 from the middle. So I know I'm going to have this point right here, so 0, 4, 1 from the middle, down 2, -2, 4. Those are going to be 2 more points on my graph. I'm going to draw my axis of symmetry in here. So my axis of symmetry goes right through the middle. We draw a vertical dashed line. We label it x equals, it's the x value of my vertex, so x equals -1. Then we're going to make a table. And a table is not required for these ones, but it's very helpful. So x, y, in the middle of my table, in the very middle, goes my vertex, -1, 6. All right, it says use A to find points to the left and right of the vertex next. I'm reading this right here because here's my how to graph, so I'm just following these steps. Use A to find the points to the left and right of the vertex. I did that right here. So 1 from the middle is 0. 1 more over will be 1. So 0, 1. If I go in the other direction, I have -2, -3. I know 1 down from 6 is 4. Or not 1 down, 2 down from 6 is 4. So I had those 2 points. Now to find my last point, I'm going to take and either plug -3 or +1 into the equation. Another option you have, go to your graphing calculator to y equals, and then plug this into the equation. Graph it so you know what to graph you're going to expect to have, and then look at the table to make sure and double check that it matches what you have. If they don't match up, either you made a mistake here somewhere, or maybe you typed something wrong in here. Common mistake is missing that negative sign right there. So you can plug this one in for x right here, or -3 in for x. Plug either of those in. It doesn't matter which one, but no matter which one you plug in, that you're going to find a value of -2. So I've got -3, -2 is down here. +1, -2 is down here. And then I'm going to draw as nice as a parabola as I can get in here with this stylus. It's kind of hard to draw. All right, there is my example for how to graph in vertex form. All right, let's do just a couple more examples here. So for this next one, we are, oops, I didn't mean to draw that line on there. I'll make this a little bigger. We're given a couple of functions here. We want to find their vertex, axis of symmetry. We're also going to describe their transformations from the parent function for this one. So I'm going to start by my vertex. So -1 tells me a +1 and then a -4. I keep that -4. So +1, -4 is my vertex, and it's an ordered pair, so I always write parentheses around it. X equals begins my axis of symmetry, always, because it's a vertical line, and it's x equals the y coordinate of my, or the x coordinate of my vertex. So my vertex is at 1, -4, which is down here. Checking out my A value is +1/2, so my graph's going to open up. So I'll label 1, -4 below it. All right, I'm going to draw in my axis of symmetry as a dashed line. Make sure my graph reflects across it. When I make that table, it's kind of like a check. So I've got those all labeled, describing my transformations. So this tells me it's less than 1. So it's a shrink of 1/2. Opposite of a minus would be a positive. So right 1 and -4 tells me down 4. So I have a shrink of 1/2. I've got right 1 and then down 4. I'm going to make my table right now while I'm thinking about it. And in the middle of my table has to go my vertex. Now if I go 1 in both directions, 1 smaller is going to be 0 and 1 bigger is going to be 2. And then remember, this 1/2 tells us if I go 1 from the middle, I'm going to go up 1/2 because it's positive. 1 from the middle, I'm going to go up 1/2. So I'm going to have these 2 points right here, 1 from the middle. Make sure I'm graphing the same color here. All right, so I'm going to have a point here and here. Those are both going up 1/2, 1 from the middle, and then up 1/2. So that's really a negative 3.5 and negative 3.5, because negative 4 plus 1/2 is negative 3.5. All right, we want to find 2 more points. So 1 more over, that's going to be an x value of negative 1. 1 more x value over here, that's going to be an x value of positive 3. So I looked at the graph and looking at my table here, yep, positive 3 is 1 more than 2. Negative 1 is 1 less than 0. And again, like I said on the other one, you can find these values a couple of different ways. One great way, since you get to use a graphing calculator, plug this equation into y equals. Look at the table and see what the table has here. You could also, and just in your graphing calculator, plug in 1/2, then parenthesis, and put either 3 or negative 1 in place of the x, not both, just one of them. Put this whole thing in and see what y value you get here. So got a few different ways of finding it. No matter what way you use, you should find that you get negative 2 for both of these values. So positive 3, negative 2 is right here. Negative 1, negative 2 is right here. And then, yep, I'm double checking and it looks like a nice parabola. Those points all look like they make the right shape. So I'm double checking my work in a few ways. I'm just looking at it to make sure it looks like it makes sense. Using my calculator to make sure it makes sense. And then also using my brain and thinking about what the equation says. All right, our next one. This negative says my graph's going to open down. A 3 says a stretch of 3. Plus 2 says I'm going to go left 2, and plus 3 up 3. So negative 2, positive 3 is my vertex. Opposite of the x, or opposite of the h, the k stays as it is. Axis of symmetry is x equals, and it's the x value of the vertex. So negative 2, positive 3 is up here. I'm going to draw in my axis of symmetry. That's at x equals negative 2. I'm going to describe my transformations here. So it opens down. Remember, you can also say reflection across the x-axis, because that's what happens. We've got a stretch of 3, so my graph should be narrower than the parent function. Our vertex moved to the left 2. And our vertex also moved up 3. So I described my movements there from the parent function. Now I'm going to finish putting in the rest of my ordered pairs. I'm going to think about it as a table. My vertex goes in the middle of my table, negative 2, 3. One smaller than negative 2 is negative 3. Another smaller is negative 4. One bigger than negative 2 is negative 1. Another bigger is 0. And then I'm going to look at my A value here. It's negative 3. So if I go 1 from the middle, I'm going to go down 3. So that's the point, negative 1, 0. 1 from the middle, down 3. and that's the point negative 3, 0. So I know these 2 points. They're both going to have zeros here. And again, it's a parabola. I'm equal spaces from the middle, so they should be the same y values because they're reflections of each other over the axis of symmetry. Now, again, to find our last two values here and here, you've got options. Either take 0 or 4, either one, plug it in here, and simplify. Don't forget your order of operations. Or put this whole thing into your graphing calculator under y equals and check out the table to see what goes here. Either way, no matter what way you find it, you should find a negative 9. It's good for you to practice. Make sure you can find that and use your graphing calculator. Now negative 9 is going to be off my table, so I'm just going to draw in my parabola from here because I can't get the rest of the points on there. Okay, our last example problem for these ones. So my last example, I'm doing the same things as before. So looking at this, I know I'm going to have a graph that opens down. It's got a stretch of 2, so it's narrower than the parent function. It moves to the right 1 and up 5. The vertex goes right 1, up 5. So my vertex is going to be 1, 5. My axis of symmetry is x equals 1. So 1, 5 is up here. My axis of symmetry, gotta find a different color so I can draw this in here. My axis of symmetry is going to be a vertical line. Vertical lines are always x equals, we're going to label it. Our graph opens down, so we're going to label the vertex above the vertex so it doesn't get in the way. All right, so I got my vertex, my axis of symmetry. Let's describe our transformations. I already said them, but it opens down, or you could say reflection over the x-axis. It's got a stretch of 2, so it's narrower than the parent function. We moved to our vertex to the right 1, and we also moved our vertex up 5. Now let's find some more points around the middle. I'm going to start my table here. Again, the vertex is the middle of our graph. It goes in the middle of our table. One more than the x value of 1 is 2. Another more is 3. One less than 1 is 0. One more less is negative 1. So they're equal spaces apart from the middle and from each other. So we should have values that repeat here around the middle. These should be the same and these should be the same. So an a value of negative 2 says from the middle, I'm going to go over 1 and down 2. So I'll have the point 2, 3. I'm going to go back 1 and down 2, so I've got the point 0, 3. So I know I have 3's in both of these spots. Oh, I did not mean to do that. There we go. So 0, 3, and 2, 3 are here and here. All right, and then again to find our last values here, you got options, either plug 3 and negative 1, pick one of them and plug it in here and simplify. I'll do that and show it to you just since I haven't yet. So negative 2 times, I'm going to plug 3 in, minus 1 squared plus 5. And I'm following the order of operations, parentheses comes first, so that's a 2 squared plus 5. Then exponents next, so negative 2 times 4 plus 5. Multiplication and division from left to right, so that's negative 8 plus 5. And finally addition, which is a negative 3. This is a negative 3 in both of these spots. So negative 1, negative 3 is down here. And just looking, that makes sense. Those 2 points make sense in this parabola. It gives us a nice parabolic shape like we would expect. All right, so that's a nice review of graphing in vertex form. Have a great night.